Hello students, so this extra screencast is aimed at showing you how to use sheet symbols, a very useful feature in Altium when you're creating schematics. So sheet symbols are particularly useful because they allow you to separate complex circuitry and reduce it into a black box component that you can use over and over again, and all it shows is the input signals and the output signals, and the complex circuitry for that component is abstracted away into a hidden level. So this level of abstraction is actually similar to if you're using functions in programming and you're creating a modular design, and in that way it simplifies your schematic from a top level view, and it actually makes creating schematics more efficient, particularly if you're using this complex circuitry over and over again. You don't have to recreate it every time. You can just drag and drop your sheet symbol object. So to be specific, sheet symbols are more useful if you're going to be perhaps controlling multiple motors and you need to design a H-bridge and logic circuit, and you will have all that complex circuitry for controlling one motor in a state that you can copy and paste for 3 individual motors. Also, if you're just reading from multiple sensors that are identical, sometimes sensors require extra circuitry that can be quite complex, and if you're having multiple of these circuits, it may be useful to have a single sheet symbol that you can duplicate. But ultimately, any duplicate circuitry that you would like to abstract away, it's recommended to use sheet symbols. It makes for a much cleaner schematic design. So we're going to show you how to use sheet symbols in Altium, and to do that I've found an example project that has a little bit of redundancy in a particular circuit that's being used. So this schematic shown here is actually a control board for a marine instrument at a James Cook University laboratory where we perform marine sensing of water quality. So this control board was for a nephelometer, which measured turbidity, deposition, and light. And ultimately there are 8 individual sensors on this PCB that have identical circuitry. So I look at this and I see some redundancy. Each one of these individual sensors has 5 volt positive and minus power supply, which is shown here. They also have 2 sensory outputs for turbidity, and they also have a control input to allow you to turn off each sensor individually so that you can save power over time, and that's simply made up by this small transistor circuit that allows you to switch off and on the power. And ultimately every single circuit here is identical. 5 volt rail here, 5 volt rail here, and all of them. These circuits are also similar, but they have a 12 volt power supply for a higher voltage sensor. So I look at this and I can see us replacing this complex circuitry with inputs and outputs with a single sheet symbol that we could duplicate 8 times rather than having to create 8 individual circuits. So in this screencast I'll show you how to transform a piece of circuitry in Altium into a sheet symbol that you can then use to duplicate over and over again. So here's our schematic and PCB document, which was designed in Altium a few years ago. And so what we're going to take you through is the steps involved to create a sheet symbol for this simple circuitry. So in Altium, a sheet symbol looks much like this. Here we have a complex audio amplifier circuitry, which ultimately we don't want to modify any further. We just want to be able to drag and drop into a larger design. And this is the simplified version here, a simple green or black box solution with inputs and outputs labeled inside of it. And that's what sheet symbols look like in Altium ultimately. A green box with a designator, a title name for where the file comes from, and all the different inputs and outputs that we've designated for it. It's also important to note that what you're doing is you're creating a separate schematic document in Altium that is linked to the sheet symbol component. So the first thing you may wish to do is to actually create your sheet symbol. And creating a sheet symbol is quite simple. You just go place and then sheet symbol tool menu, and it will look something like this: a blank green box with our default designator and default file name. Now remember, the file name will be linked to this sheet symbol, and the file is a schematic document that will contain the complex circuitry that you'll be linking to the sheet symbol forever. And when you create the sheet symbol, you're often greeted with this menu where you can modify the designator and the file name, and also the size of your object in the schematic. So to place a sheet symbol, you simply go to place sheet symbol. The first click will select the top left corner of the object, and the second click will be the bottom right corner. But before you do that, you can press the Tab key to enter the component properties of the sheet symbol. So in this case, we can modify the designator. Typically you see resistors with R1, R2, R3, diodes D1, D2, D3, and in this case I'm going to use the prefix SS for sheet symbol 1, 2, 3, 4, and so on. So this will be SS1. And my file name. So remember, your sheet symbol is linking an input-output black box to a more complicated schematic document. So whenever you create a sheet symbol, you're creating an accompanying schematic document that should also have a similar name. So in this case, I'm going to call my sheet symbol custom sensor document. And that's going to be a schematic document that I will have to edit later on. And it will create it in my current project workspace. So they're the settings I want. Now I'll place the top left and bottom right corner. And I want this to be large enough to hold our inputs and outputs. So in the case of our circuit, we have one input, this C0 signal, which will allow us to turn the sensor on and off via a switching circuit on pin 6. And we have two outputs for our custom sensor, D01 and D02. The 5-volt rails, positive and negative, are internal items that will not be outputs or inputs. They will be constant supply. So our circuitry here is basically going to exist inside of this green box, and we do that via creating a new schematic file that this will be passed into. So that's creating a sheet symbol. Now we need to actually create the circuitry. Well, what we need to do is create the symbol schematic. So actually go into that file name document and create our circuit. The easiest way to do that is to right click the symbol, sheet symbol actions, and then create sheet from symbol. And then you can begin creating your circuit with its inputs and outputs. Or if you're doing what I'm doing in this case, I already have a circuit that I've identified as redundant, and I just want to copy it and paste it into my new sheet symbol schematic. So that's what I'm going to do now. And remember, when you're in this editor, it's just working like a normal schematic editor in Altium. You can place components just as if it was its own standalone schematic. The only difference will be when you actually need to label the inputs and outputs, you'll use these objects called ports that allow us to connect them to our sheet symbol. All other components will be hidden or abstracted away, and they won't be available to see when we're at our green level of the black box. So let's create the symbol schematic following these simple steps. So the first step is to create the actual document. As you can see now, I've created a symbol that has the document linked, but the document hasn't been created inside of our Altium workspace. So right click the component, you're looking for sheet symbol actions, and you want to create a new sheet from the sheet symbol. And as you can see, it creates that file that we need to link the document. So I'm just going to save my work. And I'll save. So now it's asking to save the freshly created schematic document to the name that I've chosen. Yes. All right, so as I mentioned, you can start from scratch, but in my case, I already have the circuitry that I wish to duplicate. So I'm just going to copy and paste the circuitry. And ultimately, that's our sheet symbol. However, we need to now designate what the inputs and outputs are using ports. So as I mentioned, this is our input. It allows us to turn off and on this sensor via this header connection and switching circuit. And the two outputs are D01 and D02, which allow us to read two different sensor values. I think in this case, turbidity or light. What we need to do is delete these nets, which were previously used to designate our inputs and outputs. And we need to add in ports. So ports are just another schematic component. So I can go place, and we're looking for just single port here. Now, again, press Tab to modify your port before placing it. You can choose the name for your port. So in our case, one of our ports was called C0, and this port was the input because it allowed us to change the power of the sensor. Left click will determine the leftmost position, another left click will determine the rightmost position. And you want to make sure that the crosshair turns red as you're clicking this to tell you that it made a connection to an actual signal. Now let's place the outputs. So the output was called D0_1, and we changed its input output type to output. There are several other types. We have bidirectional, meaning something that can be both an input and output, something that's unspecified. It could be a power port or something of that nature. And we'll just press OK and place our ports thusly. So there's D01, and automatically Altium incrementing the designator for your port. And so as you can see, it's gone to D02, and that'll be my second port. And one thing you'll notice with the ports is that inputs go from left to right, from a flat edge to an arrow edge, and outputs go from an arrow edge to a flat edge, just so you can quickly determine which is an input and output. There's also some overlap here, so I'd like to just move my 5-volt rail components further out so that we can still see them. And there you have it. That's our simple circuit here. One thing you may wish to do is every time we create a symbol schematic, we would want to have the designators named appropriately. So there's only one object here, so we'd need to rename that P1 just to be a bit more cleaner as a design. And similarly, there's one transistor. Typically they're prefixed by Q, and I'll name this one Q1. So there we have it. There's a complete sheet symbol schematic. I'll save my work. So the next step, we've created the sheet symbol. We've created the symbol schematic. Now we need to actually connect them together and make sure that they're linked. We call this synchronizing the symbol. And to do this, you right-click the sheet symbol. Then you can select the option synchronize ports to sheet entries on the designator. And it will bring up a menu that looks much like this that we can use. And so here's our schematic document that's finished. We've designated our output ports and input ports. Let's go back to the sheet symbol. And as you can see, it didn't automatically update those ports onto the document. We have to do it ourselves. So right click, you're looking for sheet symbol actions, and we're looking to synchronize sheet entries and ports. Brings up this submenu. And as you can see, it's already recognized the input and output ports in the schematic, but we actually have to link them onto our sheet symbol. So typically I just grab all of our inputs and outputs, and you can go add sheet entries. However, when you do this, they're kind of linked together. They're all in a vertical or horizontal alignment that align to the edge of the board. And you may not want to do that. You may want to have better control over which side of the object your inputs and outputs are. So I'll press escape, and I'll do these one at a time. I'll place my input on the left side of the sheet symbol, and I'll place my outputs on the right side of the sheet symbol, just so it looks a little bit neater, like so. And that's all you have to do. I can close this menu now, and my sheet symbol inputs and outputs are now linked. And so I'll have my inputs going into here and my outputs connections on the right. The final step is to connect your freshly created sheet symbol into where the inputs and outputs need to go to actually connect it to the rest of your circuit. So let's do that in Altium. So if we would have a look at our previous more complex circuitry, now we've internalized that into a big green box. All we have to do, connect our net layers, the net layer C0, which is actually coming from another header on this board a bit further down. We need this pin 1 of this object, which is just a header, to go through and connect to this custom circuitry so that we can control the sensor and read the outputs. So all we have to do is I'll delete our original circuit, which we've now duplicated. I'll get a bit of wire and extend out from C0 and extend out from D01 and D02 and attach nets to them. Tab, and I'm going to name this one C0 so it connects up to our other header. I'll then need to have our output nets D01, which goes to D01, and D02, which goes to D02. And there you have it. I've replaced one of those custom sensors circuits with a simpler sheet symbol. And what we can do then is duplicate our sheet symbol for every single object. And it's a bit simpler than having to create that circuitry from scratch. So once you've created a symbol, the simplest way is to then copy and paste the symbol and connect different inputs and outputs for different uses. So in Altium, delete the duplicate circuits and copy our new custom sensor schematic. And I'm also going to copy with it the net labels and wires that I added to save time. 2, 3, 4, 5, and 6. There were 6 5-volt sensors. So let's look at our sheet symbol 2. It's no longer C0. Our input was C1, and our outputs were D1_2, D1_1. And I'll also want to rename the designator for our sheet symbol, and because we can't have two components with the same designator, so we'll need to increment. This is the second sheet symbol. And we'll continue this process for our remaining sensors. So there we've modified all 6 5-volt custom sensors and replaced their circuitry with a custom sheet symbol and just modified each output. So we're connecting the nets that were previously there now to a sheet symbol where the internal circuitry is performed in another document. So the next step that you may wish to do is to modify an existing symbol where you need to create a circuitry that's a little bit different to the current sheet symbol you have. So an example of that is the 12-volt sensors that we have in this circuit. So these circuits are otherwise identical, except of a 5-volt plus and minus rail, we have a 12-volt positive supply. So our sheet symbol document is now a little bit different, and to modify it. So one thing you can do is use the rename child sheet option. It allows you to create a fresh schematic based on the previous design and modify it thusly. So what you'll first want to do is copy our sheet symbol. We'll copy our 5-volt custom sensor, and this is what we're going to use for our 12-volt. So before I do that, I'll rename the designator to be SS7 because it's our 7th custom sheet symbol here. And what you can do now is create a fresh schematic document for this sheet symbol that's going to be a little bit different to the other ones. So right-click, Sheet Symbol Actions, and select Rename Child Sheet. Make sure you select the third option here if you're going to be modifying the document and creating a new sheet. It will copy the child document for this sheet symbol and only update this symbol, and it won't update and filter through to all the other symbols which for the 5-volt sensors. So what I'd like to do is call this custom sensor a 12-volt custom sensor and press OK. And as you can see, we've created a new schematic document specifically for this sheet symbol, and all of our other ones haven't changed. So now we want to basically edit our 12-volt custom sensor. We will remove our 5-volt rails and add in a single positive 12-volt power port. So I use the VCC power port tab to change the name, and we're looking for a 12-volt connection, and escape. And there's our modified 12-volt custom sensor. And just to verify that the link exists, you can right-click your sheet symbol and select Open the subsheet, and it links you to that exact circuitry. So this is the circuitry that will be implemented when you use this sheet symbol. Now what we need to do is replace our 12-volt sensors. I'll delete both, and we'll add in sheet symbols for those objects. So we'll have 2 of them, SS7 and SS8. All right. So there, we've used sheet symbols to replace all of that redundant circuitry for our 5-volt sensors, and then we modified one for our slightly different 12-volt sensors, and we'll save all of that. So in conclusion, we had our schematic with some redundant circuitry for several individual sensors, and it looked a little bit cluttered. So if you identify any duplicate circuitry that you'd rather not have it complicating your schematic, you can replace them with sheet symbols, and it looks a little bit more cleaner, and particularly if you have more complex circuitry. This was a simple example to show you the use of sheet symbols. One final thing to remember is how this will impact how you generate the PCB. So we've seen how to do it with the schematic, but we always need to convert that schematic into a PCB layout. So there are a couple of things that change. Ultimately it's the same process, but there's 2 notable differences. The first is that your sheet symbol components will follow a designated naming convention that is the component designator. First of all, one of our component designators may have been Q1 for that transistor and P1 for the header, and then it's an underscore followed by the sheet symbol designator, which is SS1, 2, 3, or 4. Another thing to be concerned with is that all of your components for each child sheet are placed inside of their own room. So there is some crafty things you can do with rooms, and I'll show you how to use them in your PCB layout. So there's typically 2 things you want to do. Either delete the rooms entirely or place the components individually. So let's have a look at the rooms if we were to create our PCB that has some sheet symbols inside of it. So now what we wish to do is update the PCB layout from our schematic by pressing Design, Update PCB Document. And it has the list of changes that it needs to make. Of note are the several rooms that will now exist. So previously we only had one room for one schematic document. Now, because there's several schematic documents with our subsheets, there's several rooms that will be used, and we can do some useful things with those. All of the changes were successful, and you can zoom out to see that the components were added in. So as you can see, this is the room of components that exist in our main schematic for the entire project. And then we have 8 almost identical rooms that contain all of the components inside of our sheet symbol. So you may wish to have one identical format that each of the rooms should conform to. So we can actually achieve that with a couple of steps in Altium. So format one of your rooms and then copy that format to the rest of them. So you can only do that if you have an identical subsheet. So the steps are: format the components for one of your rooms, select Design, Rooms, and Copy Formats. And then you can select the source and destination rooms that you want and move them around as you see fit. So let's have a quick look at how to do that. So what I want to do is have a single format for this room and copy it to all of our other ones that I can. So the format you may wish to have might have better alignment between the transistor and the header. So in this case, we may wish to have the header at the top and our transistor down the bottom, something like that. And you may even wish to minimize the room so it just contains those components. And at this stage, you may even wish to wire up the single connection that we have. So there's the format for one room. So now use the tool Design, Rooms, and we're looking for Copy Room Formats. So it brings up this crosshair dialog. And all you want to do is first select the source format. So I want to copy the format that I just made, so I'll click it first and apply it to destination format, which is that one there, and just press enter. And as you can see, it conforms the second subsheet to our first format. And we'll go through and do that for each. Now I also want to do it to our 7th and 8th, but these are 12-volt custom sensors. And you may remember we created a different sheet symbol for these. So if I tried to do the room copy, it notices that the source and destination rooms are actually from different subsheet classes. So I need to reformat these separately. So I need to have a similar format. So I wish to move the transistor a little bit down, the header at the top, and I even created a interactive routing connection between those two pins, and that's all that needs to be connected in the room. Save space, and then now I can do the room copy again via Design, Rooms, Copy Room Formats, select the source first, select the destination, and then press enter. And there you can see we've created another duplicate room, and that just makes it a little bit easier, a little bit more efficient when you're placing in identical components. And you can especially see if you had a sheet symbol for a very complex circuit with a lot of components, you don't want to place all of those components individually for each circuit. So copying room formats is quite useful for that. So that completes the screencast for today. We looked at a few things using sheet symbols, and they will be useful for any project where you have duplicate circuitry. Thanks for listening.